We start our lecture from chapter 6, which is called normal distribution. So I will move step by step in every step of the questions. So first I explain how to transform x variable into standardized z normal distribution. So here you can see that this is a bell-shaped figure. This is a bell-shaped figure. This is called normal distribution. If it is a bell-shaped, then it is a normal. So in normal distribution, our mean, median, and mode are same or so-called similar. Then we can say that this distribution is a normal distribution. So how to apply normal distribution? Any normal distribution can be transformed into the standardized normal distribution. So we will be given data in x and we will transform this x variable into z units. We will transform x units into z units. This is the first step to apply normal distribution. We will solve some examples so that you can practice it, you can master it, you will be familiar with this, how to transform x units into z units. There is a very simple formula to transform x units into z units. So to do so, we need mu, mean, sigma, which is standard deviation. So here, when you will be given mu and sigma, you will simply substitute them here corresponding to value of x. We will get z units. For example, here you can see if x is distributed normally with mean of 100, as I said, you will be given mean, you will be given standard deviation, which is 50, and we want to convert x 200 into z units. So we will substitute all the values into this simple formula. So x is 200, mean is 100 divided by standard deviation, so z will become 2. So this says that when x is 200, then mean and then z distribution will be 2. So here I can give you some more examples. Like we assume that, let's say mu is 65 and we have sigma 9. So we want to transform x 54 into z units. This data will be given. So the formula is z equals to x minus mu divided by sigma. Here we will substitute 54 minus mu 65 divided by sigma. So it would be minus 1.22. So here you can see we will be given this information. Through this information, by using this formula, we can transform x units into z units. So here, let's say we take another example where we say that x is 300 and let's say your mu is 100 and sigma is 50. So when you will transform into z unit, 300 minus mu divided by 50, so it is 4. So when x is 300, our z is 4 unit. This is how we transform x variable into z variable. And I give you one more example. For example, we want to know that probability x is less than 86 and greater than 70, where mu is given 65 and sigma is 9. We transform both x's one by one. We can say this is x1 z1. So we will substitute x greater than 70 minus mu, which is 65 divided by 9. So we can get z1 minus when x is 70, you can do the simple calculations. I think it is 0.56. Similarly, we can get z2. For z2, we will substitute this x2 minus 65 divided by 9, so it is 2.33. So this is how we transform whenever you are given x variables. This is how we transform them into z variables. So I give you one more example. Let's say mu is 65. I'm repeating again, you will be given mu and sigma. If you are not given mu and sigma, you will be given data like you did in your first assignment, and you can easily calculate mu and standard deviation. That is why I gave you that assignment to revise how to calculate mu, which is mean, and standard deviation. We want to know that what is the probability that x is greater than 80. To do so, first we transform x variable into z. So 80 minus mu over 9, so it is 1.67. so this is how we transform x variable into z variable. So this is the first step to apply normal distribution. I call this video 1.11. Now in video 1.12 I will tell you how to read the value corresponding to z. After converting from x to z, then how to read the value corresponding to these z values.